Next, let's solve example number 5. Example number 5 says that verify that 3 minus 1 comma minus 1 by 3 are the zeros of the cubic polynomial. P of x is equal to 3x cubed minus 5x squared minus 11x minus 3. Here we are given with a cubic polynomial. We are going to verify these 3 and the minus 1 and the minus 1 by 3 as the zeros of this cubic polynomial, and further we are going to verify the relationship between the zeros and the coefficient. Okay, let's solve it. First, how will we verify these 3 as the zeros of this cubic polynomial? First, we will be putting the value of x with 3, and if we get the value of this quadratic polynomial 0, then automatically these 3 will be the zeros of this cubic polynomial. Okay, let's find out. First, let's find out the value of a, b, c, d. How will you find out? First, we will be comparing the given polynomials with the general formula. Comparing the given polynomial with ax cubed plus bx squared plus cx plus d. We get, comparing these two, we get a is equal to 3 and b is equal to, here we get minus 5, and c is equal to, we get minus 11, and d is equal to minus 3. Okay, let's verify this 3 and the minus 1 and the minus 3 as the zeros of this cubic polynomial. Here let's put, instead of x with 3 is equal to 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3, which gives 3 cubes gives 27 is equal to 5 minus 5 into 3 square gives 9 minus 11 into 3 gives 33 minus 3 is equal to 27 into 3 gives 81 minus 5 9 are 45 minus 33 minus 33 minus 3. Adding these 3, 45 minus 33 minus 3, we get 45, 33, we get 8, 7, adding 3 again, we get 81. Minus minus is plus, so the minus is plus, but the symbol will be written as minus. So 81 minus 81 is equal to 0. So the value of p of 3 is 0. Therefore 3 is the zero of this cubic polynomial. Again, we will substitute the x with minus 1. P of minus 1 equal to 3 into minus 1 whole cube minus 5 into minus 1 whole square minus 11 into minus 1 minus 3, which gives minus 1 whole cube. The power is odd, so it will give minus 1. Minus 1 and the 3 multiplying, we get minus 3 minus 1 whole square. The power is even, so it will give positive. So 5 into 1 is 5. Here the minus and the minus, we get plus 11 minus 3, which gives, adding the minus part, minus 3 minus 5 gives minus 8. Minus 8 and the minus 3, which gives minus 11. Minus 11 plus 11 is equal to 0. So the value of p of minus 1 is 0. Therefore minus 1 is the zero of cubic polynomial. Again, let's find out with the p of 1 by 3. P of minus 1 by 3. 3 into minus 1 by 3 whole cube minus 5 whole into minus 1 by 3 whole square minus 11 into minus 1 by 3 minus 3 is equal to 3 into, here the power is odd, so it will give out minus 1 by cubing, we get 1 by 27 minus, here the power is odd, so it will give positive 5 into 1 by 9. Here the minus and the minus become plus, which gives 11 into 1 by 3 minus 3. Here dividing this to 3, 9 are 27, we get 1 by 9 minus 5 by 9 minus 11 by 3 minus 3. So taking out LCM, we get the LCM of 9 and the 3, we get, if the smaller one can divide the larger one, so automatically the LCM will be 9. Dividing this to 9 divides 9, we get 1. Multiplying 1 with the minus 1, we get minus 1. 9 divide 9, we get 1. 1 with the minus 5 multiplying, we get minus 5. 3 divides 9, we get 3. So multiplying 3 with the minus 11, we get minus 33. Oh sorry, plus 33. It must be plus 33. And here the denominators of 3 is 1. So we divide 1 divided by 9, we get 9. Multiplying 9 with the minus 3, we get 9 3 are 27. Minus 27. So adding the minus part, minus 27 plus minus 5, which gives minus 32, minus 32, minus 32, minus 1, which gives minus 33. Minus 33 plus 33 divided by 9, which gives 0 by 9 is equal to 0. So P of minus 1 by 3 is 0. Therefore, minus 1 by 3 is a 0 of this cubic polynomial. Okay. Next, therefore, we can write this as, therefore, 3 minus 1 and minus 1 by 3 are the zeros of 3x cubed minus 5x squared minus 11x minus 3. Okay, we can take this as alpha, beta and gamma. Okay, let alpha equal to 3 and beta equal to minus 1 and gamma equal to minus 1 by 3. We know that alpha plus beta plus gamma is equal to, we already know from the formula that alpha plus beta plus gamma is equal to minus b by a, and alpha beta gamma plus gamma alpha is equal to c by a, and alpha into beta into gamma is equal to minus d by a. We are going to prove this one. Okay, now first one is the alpha plus beta plus gamma. Alpha plus beta plus gamma is equal to, here the value of alpha is 3, the value of beta is minus 1, and the value of gamma is minus 1 by 3. Subtracting these two, we get 2 minus 1 by 3. Subtracting this, we get 3, 2 are 6 minus 1, we get pi by 3. But we need to write minus b by a, that is, which is equal to, we leave a blank here and write minus b by a. What is our b here? The value of b is minus 5, so we write minus 5 here, and divided by the value of b is minus 5, so we write minus 5 here. There is, for the formula there is minus, so we write minus here. And for value of a, what is the value of a? The value of a is 3, so we write 3 here. So multiplying these two, minus minus plus, we get 5. Here pi by 3, so it is correct. We verify it. Next one is the alpha beta plus beta gamma plus gamma alpha. Alpha is 3 here into beta is minus 1 plus here beta is minus 1 into gamma is minus 1 by 3 plus gamma is minus 1 by 3 into alpha is 3. So it gives 3 into minus 1, we get minus 3. Minus minus plus, we get plus 1 by 3, and cancelling this 3 with the 3, we get minus 1. So we write minus 1 here. So minus 3 and the minus 1, we get minus 4 plus 1 by 3, we get 3. 3 4 are 12, minus 12 plus 1, we get minus 11 by 3. Leave a blank here and write C by A. What is our C? Our C is minus 11. So we write minus 11 here. And what is our A? Our A is 3. So it is same, minus 11 divided by 3. So which verifies the zeros and the coefficient. Next is this one, alpha into beta into gamma. Here our alpha is 3 into our beta is minus 1 into our gamma is minus 1 by 3. Cancelling these two, we get minus 1 minus 1, we get plus 1. Leave a blank here and write minus d by a. What is our d? Our d is minus 3. So we write minus 3 here. For the formula minus, we write minus here. And for a, we write a. What is our a? Our a is 3. So we write 3 here. Minus minus plus, we get 3 by 3. Dividing these two 1, 3 by 3, we get 1. So it verifies the results. Here it finishes.